want to translate the number subtracted from 7 into a mathematical expression. Okay, I'm just going to talk out loud right here and show what I'm thinking. So what I'm thinking is, first of all, when I read the number, I think x. And when I read subtracted from, I think that x is going to have to go at the end, because subtracted from throws whatever is after that into the front, I guess. So when I say the number subtracted from -7, that would translate as -7 minus x. X is subtracted away from that -7. Okay, so this would be my final answer. And again, the marks I've written up here, that's kind of me thinking out loud. That's not necessary in this one to show the work. I was just trying to show my thought process to help you think about how you would translate this one. Do something similar on the next one. 2 minus the product of a number and 4. So 2 minus, that's flat subtraction. It's not subtracted from or taken away from. So I'm going to say 2 minus. Now I've got minus what? And the rest of this is what is being subtracted. So it's 2 minus the product of a number and 4. So I know product is multiplication, and what am I multiplying? I'm multiplying the number and 4, and the number, of course, is x. So the product of number and 4 can be written as x times 4, or it's more commonly written as 4 times x. Okay, so to be fully simplified, it is true that the 4 should be written in front of the x. There's a property of multiplication that you can write the x or the 4 first. It doesn't matter, because that's the way multiplication works. It is associative or commutative, both. Okay? So, this would be my correct final answer here, and again, I was showing my thought process. Let's go on to the next page. A couple more translations. The first one, -4 times the difference of a number and 7. So we'll do this one as well. -4 times, now what it is multiplied by is the difference of a number and 7. Okay, so when I'm multiplying it by a difference, that's an indication of parentheses. It's not -4 times a number. It's not -4 times 7. It's -4 times the whole difference. So I'm going to make sure I have parentheses right here for my difference, which is my subtraction. Okay, so that was my thought process again, and this would be the completed solution. Okay. And I will leave letter D. You can try that one and check your answer. I'm going to move on to, so let's look at a couple examples of solving and how to show our work here. In the first case, I've got some distributing to do, so I'm going to start with 4 times 6 and 4 times 2x. And then we're going to try to get the x by itself, so I don't have any x's anywhere else, just the 8x. This 24 needs to go to the other side, so I'm going to subtract that 24. Showing the subtraction is a good step. I'd like to see that. Okay, and now I've got 8x equals -24, and again I'm going to show that I'm dividing both sides by 8 to get that x by itself. I'm going to write real small right here. My x is equal to -3. Okay, so that would be how I would show my work in a problem that I'm solving. Okay, I'm going to try to write a little bit neater in the next example. I kind of went off the side on this one, so let me be a little more careful here. I'm going to show my work again. I'm starting off with 4 plus, and my distribute, so that's 3x plus 3 times 2 is 6 equals the 10. And again, deliberately showing my work right here, showing my distribute, showing next, when I add my like terms, I get 3x plus 10 equals 10. And again, this is my only x, so I want to subtract off the constant. So I'm subtracting 10 from both sides. Okay, so I end up with 3x equals 10 minus 10 is 0. And if I divide both sides by that 3, that gives me that x equals 0 divided by 3 is 0. So I get 0 for the answer to this one. Okay. All right. I'm going to move on to number 30 and look at showing my work in this case right here. Okay, so again, I would like to combine like terms where possible. So 3x minus 12x is -9x equals 24 minus 9x. Okay, now I've got x's on both sides. I need to get them to be on the same side. So I'm going to take the opposite of a negative 9x and add a 9x to both sides. In this case, a negative 9x plus a 9x is 0. I do not need to write 0x. There aren't any x left. Negative 9 and positive 9 add to 0. So just 0. And then my 24. Okay? Again, negative 9x and 9x add to 0, not 0x. No such thing as 0x, you would just write 0. Okay? Now in this case, unlike the one up here where when I did my division, I was left with 3 divided by 3 is 1x. So I was left with the solution of x equals 0. In this case, I completely eliminated my x's. So this seems inconsistent. Oops, inconsistent. And since it is inconsistent, we would actually answer no solution. Anytime I have a false statement, something that's not true, it's inconsistent, and it has no solution. So no solution would be my final answer there. Okay. I'm just going to skip around on a couple of these. Let's try another one. I'll pick 34 for or 32 for example. Let's multiply those together. 12 minus 4x plus 5 equals 6x plus 9. Okay. Combine like terms. So I've got myself a negative 4x plus a 17 equals that 6x plus 9. And again, I want all the x's on the same side. So I'm going to take my negative 4x and I'm going to add it to the other side. I like to move the term that has the smaller coefficient. Negative 4 is smaller than 6, so I'm adding the opposite to both sides. Not necessary to do it that way. I could have subtracted the 6 from both sides and I'd come out with the same answer. So that gives me 2x now, plus 9. Now that the x's are all in one spot, it's time to show our subtraction of this 9. Okay, so that gives me, I'm going to write really tiny now, 8 equals 2x. And if I divide by 2 on both sides, that gives me 4 equals x. Okay. Alright, so hopefully I give you a little bit more space on your test. This is just a sampling I typed up real quick. Okay. Again, I'll skip around a little bit. Looks like 34 is a good one to do. There's some fractions there. Let's talk about showing our work in that case. Okay. So with those fractions, let me write the problem down because this is a little bit in the way. Okay. I've only got x in one place, so I want to first deal with this 1/2 to move it to the other side. So the opposite is going to be add a half. Alright, and that's going to give me x over 5 equals, over 5 is a little sloppy there. Okay, so I can't add these yet. What I need to do is a middle step right here. I'm going to get a common denominator so that I can add them. So I'm going to write my 7/10 plus with a common denominator. I'm going to multiply this one by 5 on top and bottom, so that'll be 5/10. Okay, so I'm going to end up with 12/10. So it's important to show my common denominator work somewhere in the process. I like to just draw the arrows over so that I can do it right there. Okay, that would work, but I do need to show that I'm getting a common denominator or find a common denominator at some point in this problem. Okay, now it looks like I've got x divided by 5. The opposite of division is multiplication, so we're going to make sure that we multiply both sides by 5. 5 goes into 5 once, so that gives me x, 1x, or just x equals 5 goes into 5 once, 5 goes into 10 twice, so it gives me 12 divided by 2, which simplifies to x equals 6. Okay. And again, this 12/10 right here was not a reduced fraction. I didn't have to reduce that until I was done with my final answer. Like my final answer right here does need to be reduced to that 6. Okay, so let's see what we have next. Okay, I want to translate some English phrases into equations this time and solve the equation. 4 minus the difference of a number and 6 is 15. Okay? So I've got my 4 minus the difference. Okay? So both of these are subtraction words. Both minus and difference are subtraction words. But I have 4 minus the entire difference of a number and 6. Okay? That's going to be an indication of parentheses. 4 minus what? 4 minus the entire difference right here. So I've got 4 minus the difference of a number and 6. Okay? Those parentheses are important. It's 15 right here because they're going to indicate I'm going to need to use a distribution right here to solve this. Okay, so I'm going to solve it over here, just writing it down again and give myself a little bit more space underneath. Okay. When I do my distribution, I have a negative x, and then negative negative will make that a positive 6. Combining the like terms, so I've got negative x and then a plus 10. Both the 4 and the 6 are positive. I got myself a 15 right here. And I want to subtract that 10 from both sides so I can get the x by itself. So negative x equals 5. And then we're just going to multiply both sides by a negative 1 so that my two negatives will turn that x into a positive. So it looks like I get negative 5 for my answer. Alright, so again, that was showing my work. This one wanted me to do two things. Translate. So it's really got two answers. The first answer is the direct translation. The second answer is the solution to that equation. Okay. Alright, I'm going to finish up this part 2 video with 36 and 37 right here, solving an equation for a variable. Okay. And I think I will do 37 first, then go back to 36. This equation I want to solve for s. My s is right here. I only have one s. So first thing I need to do is get rid of this 9. Add it to the other side. Okay. Now, I don't know what r plus 9 is, so I just write r plus 9. R plus 9 is r plus 9. Okay. And then I've got my VST. Now, V and T are both multiplied by S. So if I want to get rid of them, I can divide by both of them. And it's totally okay to divide by them both at the same time. Okay, that'll make my V's and my T's cancel. And so, again, I can't finish that division, but I can say that my solution to this one is S equals R plus 9 divided by VT. So I'm showing my work right here. And let's go back to 36 and show our work on this one. I want to solve for this x. I've got the add 3. Got to get rid of that. So we got to say subtract 3 to both sides. So we're going to look like right here, y minus 3 equals 1/2 x. It's my equal sign. Okay. And again, to get rid of 1/2, that's multiplication. The opposite would be to divide by 1/2, but we don't really write divide by 1/2. What we would do instead, if you're dividing by a fraction, is we would multiply by the reciprocal. So we're going to multiply both sides by 2 over 1. And when I write it on this other side, I'm just going to notice that 2 over 1 is 2, right? So I'm just going to multiply this side by 2. Okay. So I've got 2 y minus 3 equals, and again, 2 goes into 2 once, it gives me just the x. A couple notes about this answer right here. It's extremely important that I either have parentheses or have distributed. That 2 could be distributed to give me 2y minus 6 equals x. And I would actually take either one of these. I'm not going to be, I don't care. It doesn't say it's got to be simplified. It just wants the x by itself. So either one is perfectly fine in this situation. But it's not okay to have something like just multiply the 2 over and have it written like this. I mean, that's not the same. We can't not have those parentheses or not have had them and distributed. Okay. Alright, I'm going to end this one right here. And we'll start the next one by talking about percentages and some application problems.